we need to make sure that you understand which quadrant we're talking about. So the XY axis, split this into 4 quadrants, right? And we're going to start on the northeast corner. And we're going to go counterclockwise. So this might be new information. I'm assuming it probably is. Okay, never mind. Let me get there. Okay, so here we go. This is number 1, is the northeast corner. This is number 1. This is quadrant number 1. Quadrant number 2, we go around counterclockwise. This is 3, and this is 4. So in case you didn't know that, now you do, just like that. So the positive quadrant is where we start with number 1. That's considered the first quadrant, and then you go backwards. I don't know why, they just did. That's just the rules of the game. I think because the first coordinates would be positive in both of those places. No, they wouldn't. Never mind. I don't know why. Okay, so I need to know, I think this is review for you. So, Jonah, what are the coordinates of point A? We're going to go down that whole line. So Jonah, Micah, Adrian, Logan.
So it would be 2 and then 4.
Okay. Micah, point B.
0, -3.
0 on, oh no, wait a minute. No, because 0 is on the X, and you're telling me to go sideways. How far?
3.
Yes. So we're going to go -3, and 0 is in the Y spot. So you have the 0 right, but it goes on the Y spot, because B is to go left, -3, and then don't go anywhere. Okay, Adrian, C.
6, -3.
6 to the right and down 3. Oh, that's weird. Okay, Logan, you're on D.
0, -3.
So don't go anywhere left and right. Just go down 3. Okay, how about O? Isaiah?
0,
0, 0. All right, good. So let's write the coordinates of the point in the second quadrant. So what are the points in the second quadrant? Write the coordinates of it. There's only one. So, Evan, do you know the point that's in the second quadrant?
Yes.
What's it called?
-3.
Okay, are we talking about E?
Yes.
Okay, so we're going to go -2, and then we're going to go up 3. So -2, 3. Make sense? Okay, good. Write the coordinates of the point in quadrant 3, Hannah. What is the point in quadrant 3? Do you know what it's called?
F.
F, right. And write the coordinates of it?
It's -4.
Uh-huh.
-3.
Yes. So go to the left 4 and go down 3. Y'all good? Okay. So complete the following table using positive or negative. So in the first quadrant, do the X coordinates have positive or negative? In the first quadrant. Are my X coordinates positive or negative in the first quadrant? Positive. How about in the second quadrant? Negative. Because I have to go to the second quadrant, I have to go to the left, right? How about to go to the third quadrant? Will my X part be negative or positive? Negative. And how about in the fourth quadrant? Somebody else? Positive? Yes, ma'am. Okay. How about the Y coordinate? In the first quadrant, so all of these here, is the Y coordinate of those positive or negative? Bailey? Positive, right. In the second quadrant, this over here, Mia, will the Y coordinates in this quadrant be positive or negative? When you go over, are you going to go up or down? Up, so they'll be positive, right? And how about in the third quadrant? So in this quadrant down here, what's your name? Owen. When you go over and you come here, are you going to be going up or down? You'll be going down, so what will the Y coordinates be? Right. Courtney, in the fourth quadrant, what will the Y coordinates be? Okay, good. Turn the page. Okay, sometimes we have done this quite a bit in Math 9, in your Math 9 book. If you remember, we had almost exactly this picture. So I think this will be reviewed, but some of you weren't here for Math 9, so we'll talk about it. 3 toothpicks are used to form a triangle. There's an example of a toothpick. So I'll give you a little picture so you know what a toothpick looks like. A second triangle is formed by, so there they put 3 of them together and they get this little triangle. Then they put 2 more toothpicks together and they make a second triangle, and then of course if you put 2 more you get a third triangle. So you keep adding these 2 toothpicks at a time and you keep getting more triangles in your picture. So they say draw the next 2 diagrams. Okay, this would be the next one, and then I would have one more that would look like this, right? That's how the next 2 would look. Then it says complete the table relating to the number of toothpicks to the number of triangles. So notice the number of triangles is first. When I have 1 triangle, I have 3 toothpicks. When I have 2 triangles, how many toothpicks do I have? 5. And when I have 3 triangles, I have 7, and then 9, and then 11, right? You see the pattern? So this is just like that pattern building thing that we've talked about in grade 9, where you can just see what's happening every time. And then it says represent the data from the tables on the grid. Okay, so a little bit hard to put triangles and toothpicks on the grid because they both start with T. So we're going to put T for triangles and P for toothpicks. Okay, we're going to focus on the picks. All right, so when we have 1 triangle, we have 3 toothpicks. 2 triangles has 5. And we can go on up. Right? So that's our information. By the way, would you connect those dots? Should I draw a line between the dots? Some are saying yes. I have more than one saying yes. Anybody want to say no? No, do not connect the dots. Why would the answer be no? Well, is it possible to have 1.5 triangles? It's not a triangle unless it is enclosed. So we don't have any information to go in between this, right? Do you understand? You can't have 1.5. It's either a triangle or it's not a triangle. It's not 1.5 triangles. So we do not connect the dots. We do not put information in between. Just, oh, that was the question. I thought I was making it up. Okay, no, it does not. Can't have part triangles. But no. All right. So describe in words the relationship between the number of toothpicks and the number of triangles. Describe it in words. If I tell you I want to know how many triangles are there when you have, let's say it backwards. How many toothpicks will it take to make 14 triangles? Now listen, boys. If I have 14 triangles, how many toothpicks is it going to take to make my thing? What are you going to do? Times it by 2 and plus 1. Now the most common response is, oh, I know how the relationship is. I'm just going to keep adding 2 every time. It's true. You see how those 3, 5, 7. If you just keep adding 2, you will. But if I ask you, what about when there's 25 triangles? Well, you have to make this massive chart. You're going to have to add a whole lot of 2's together. So there has to be a relationship between this 5 and this 1. 11. There has to be a relationship between this 3 and this 7. Quit going this way and go between the 2. Do you see it? So when I give you a 4, how are you going to get a 9? So Mackenzie said, times it by 2 and add 1. Yeah? Do you see that relationship? Instead of saying, well, I'm going to add 2 1975 times, okay, go down instead. So I'm going to say double this, or multiply the triangle number by 2 and add 1. Okay. Now write an equation. I will know how many toothpicks I need if I take 2 times the triangle number and add 1. You see the difference between it? Now I had a little, we'll talk about that later. So use this equation to determine the number of toothpicks if there are 27 triangles. So I need toothpicks, I'm looking for P. If I take 2 times 27, I'll add 1, correct? 27 times 2, 54. 1 more is 55. So you will need 55 toothpicks to make a shape that has 27 triangles. Does this seem vaguely familiar to you? Remember doing this a little bit? And let's use that same equation to determine the number of triangles if there are 83 toothpicks. So 83 goes in for my P. Do the math. Do the algebra, right? Subtract 1. Divide by 2. You get 41 triangles can be made if you have 83 toothpicks. Yeah? I divided by 2. I didn't show that in the process, but we know that. Okay, here's one. Students in a physics classroom determine the resistance in an electrical circuit by measuring the voltage when a current was passed through the circuit. Put a little current through your circuit and see what happens to the voltage. The table below shows the results. There's your current, and there's your volts. So the more current that's going through, more amps, then the higher the voltage. Represent the data from the table on the grid. So go put this on the picture. We need I and V. Now here's a good question. How do I know? Is there a rule of where to put the first line? Does that go on the horizontal or does it go on the vertical? Horizontal. X is first. So whatever goes first here goes on my x-axis, which is down here. So this is going to be my current. So this is my I. That means this is my voltage. Okay. Then I need to put a scale on this thing. Now, on the current, what do you want to do? You pick it, you just have to be consistent. What do you want to put for a scale along the x-axis? 0.5? Sure. Okay, so this is 1, 2, 3. Okay, what is super important about this? Now notice, you can't make, each step has to be the same amount. So Evan and Owen, I nailed this home last year to these kids. Each box has to have the same amount of space between it. So if you're gonna go with the first box is 0.5, then every box has to be 0.5. Some kids go like this. Ready? Everybody watch. Some of you in years past will go 1, 2, 3, 4. And they don't think this matters. It matters. You can't have that many spaces and then just pick a spot to start with 1. We're not going to do that, okay? Whatever you start with, if you want to call that 1, then you have to make 3 spaces for the next one, right? You understand? Okay, so we have to make sure that we make this accurate. It matters. Okay, what do you want to use for a scale going up? We have to go from 6 to 48, so you want to go to like 50, right? How do you want to move up to 50? By 1s, 2s, 5. She's saying by 2s. 2, 4, 6, 8, 10. I'm just going to mark the 10. 2, 4, 6, 8, 20. You can choose what you want. So that would be, this would be 30. Then we have 40 here. And then 50. Okay, so every movement, every box is the same. Okay, and then we put it on. So 0.5 and 6. 1.5 and 3. Oh, sorry, 1.5 and 18. 3 and 36. 3.5 and 42. And 4 and 48. Did I do that right?
Yeah.
I did. Huh. All right. Does it make sense to join them together? Someone said yes. Why are you saying yes?
Because you can have point voltage.
Because you can't what?
You can have a decimal voltage.
Yeah,
In
voltage
between.
is continuous, right? When you turn the light on, unless you have a short in your line, it's not like, right? Like the lights aren't coming on for a second. Like current is continuous. Water flows currently. I've never seen water skip in a creek unless you were at the Red Sea or the Jordan River, right? Those cases, the water stopped and did not flow. But water flows, current flows, it would make sense to connect the dots, absolutely. What page are we on? 390. Okay, so put yes in there and write it's continuous. This is supposed to be a straight line. I feel like I made a mistake somewhere.
It's right.
Yes, it does. Current is continuous. Okay, use the graph to determine the voltage for a current of 2.5 amps. So now we can just go to 2.5 amps. Well, I could make my line. Okay, I'll try.
Sorry for the interruption, but could Mrs. Algra please call the office? Mrs. Algra, please call the
Okay,
office.
that is a pretty
Thank
good
you.
line after all. Okay, so for my 2.5, I'm just gonna go over here to 2.5, and I'm gonna go up this line and see where it crosses, and it looks like it's right there at 30. Right?
Yeah.
Okay, and anything else? Write an equation expressing V in terms of I. Oh my word. V in terms of I. So I'm going to say, remember when you write your equation, it's always the second letter first. So first goes on the axis, this is your X, this is your Y. So I'm going to say V equals, okay, I got to come up with the equation. How will we know how to make this equation? Is there something I'm timesing by? Can you tell? How do I get from 3 to 36 and 4 to 48? Times it by 12, right? I'm going to go 12I. There's your equation right there. Wasn't so hard after all. And use the current the equation to determine the voltage when the current is 6.2 amps. So V equals 12 times 6.2. Do the math. 72, 76, what is it going to be? 74.4. And the last one says the resistance, R ohms, is calculated from the equation V equals IR. So V equals IR, state the resistance in the electric circuit. Well, look at this right here. Compare these two. Do you know what the R is? Well, it's not the V and it's not the I, so it has to be the 12. Right? So R is 12. All right, turn the page. On this next page, it talks about discrete and continuous variables, and that is what we were just talking about when we talked about connecting the dots. If you don't connect the dots, if we're talking about selling pizza, or buying a pair of shoes, or t-shirts, or a book, or people going to the concert, it is not continuous. You don't have 1.7532 people, okay? we have to have whole people. Yeah. And so, but if you're talking about water flowing or time, or what would be some other examples of things that are continuous? Time is continuous, we don't jump in time. Water, current, what else? If you're driving in a car and you're driving from here to Great Falls, unless your car hops a lot, unless you're learning to drive a stick shift, you're probably, that distance is continuous, right? And time. So those are examples of continuous things. So time taken to complete a 100-meter sprint, continuous. Put a C on it right now. C on continuous 100-meter sprint. The number of students who pass Math 10, that is discrete. We will not connect the dots for a discrete question. The height of students. Now this one is a bit ambiguous. Are you talking about the heights if I just went through here and found the heights of each of you? No. This question means it should say the growth of a student. So as you grow, that's what this is talking about. So your height over the years, is that continuous or discrete? Quick. Continuous, yes. Your shoe size. Now not how your feet are growing, but when you go to the store, would the shoe sizes be discrete or continuous? Discrete. You can't say, you know what, I need mine 1/8 of an inch longer. Can we go to the next size? They're gonna be like, I have 8 and I have 8 1/2. I do not have 8 1/4. Right? So your shoe sizes are discrete. Okay, you have some questions again quickly. Do those questions in your book. I usually do 2 lessons at one time.